Assalamu alaikum everyone. Today I will solve this problem by using the bisection method. The problem says find a root of equation x cube minus 4x minus 9 equals to 0 using the bisection method correct to 3 decimal places. So when we are starting the problem, first we have to find the interval in which the root actually lies. For that we have done some initial iterations starting from x equals to 0 then till x equals to 3 to find where the root actually lies. So we can see that when x is equals to 0, f of 0 is coming negative minus 9, and when x equals to 1, f of 1 is also negative, that is minus 12. When x equals to 2, the f of 2 is again coming minus 9, that is still negative. But when we reach x equals to 3, the f of 3 is positive 6. Now we can see that the f of x value sign changes between x equals to 2 to x equals to 3. So our interval in which the root actually lies will be x equals to 2 and x equals to 3. So for our initial approximation as first approximation to the root by using the bisection method will be x1 equals to half 2 plus 3 equals to 2.5, and we will now check the value of f of x1 by putting the value of x1 into the given equation, and we found that it is coming minus 3.375, that is negative. So the root will lie in an interval whose f of x value f of x is have the opposite sign. So we can see that as it f of x1 is negative, and previously for f of 3 the value is coming positive. So the root must lie between x equals to 3 and x1, that is 2.5. So our second approximation to the root is x2 equals to half x1 plus 3. This is x1. I made a mistake, so that's why. So for our second approximation of the root is x2 equals to half x1 plus 3 equals to given half 2.5 plus 3, that is coming at 2.75. So we will now check the value of f of x2 by putting the value of x2 into the equation. So that is coming positive 0.7969. Now that is positive. So the root must lie between x equals to 2 and x equals to 1. So for our third approximation to the root is x3 equals to half x1 plus x2 equals to half 2.5 plus 2.75, that is coming 2.625. Now we will again check the value of f of x3 by putting the value of x3 into the equation, and we found that f of x3 is coming minus 1.4121, that is negative. Now the root must lie between x2 and x3. So our fourth approximation to the root is x4 equals to 1 over 2 bracket open x2 plus x3 bracket close. So that is coming 2.6875. Now repeating this process we will obtain the following successive approximation, that is x5 is equals to 2.71875, then x6 is coming 2.70313, x7 is coming 2.71094, and so on till we found that x10 is 2.70605 and and x11 is 2.70654. So where do we actually stop? We can see that in x equals to 10 and x10 and x11 that when x10 and x11 is written to correct to 3 decimal places as we were told in the problem, are similar. Here you can see that x10 is 2.70605 and x11 is 2.70654. The three decimal places are 706 and they are similar in x11, that is 706. So when this occur, we will stop and we will write the root. So the root correct to three decimal places is 2.706 and that will be our answer, and we will stop our bisection method here. So and a note here is that if we were given any pre-specified accuracy of f of x, say exponent 3, exponent minus 3, or exponent minus 4, so when it is reached, we will stop there and state the root, or we can proceed further with the bisection method till the desired accuracy is achieved. So we can write the value of root when the desired accuracy is reached, or we have reached the pre-specified accuracy of f of x. So for this problem, our answer, our root is 2.706. Okay, so thank you for watching, and for any questions you can comment below the video, and my email address will be given also. So thank you for watching.